Hello and welcome to this solution video. Thank you very much for clicking on that thumbnail. This is the solution video of Approaches and Analysis, Paper 1, November 2021, IB Mathematics. The question 1. Question 1 says that derivative of a function is cos x minus pi by 4 and additional information is given here. Find y in terms of x. What hiddenly they are trying to ask you is to find the equation of the curve. Equation of the curve is y in terms of x. That's what it is, right? And that's what they're trying to say. That means integrate dy over dx equal to cos x minus pi by 4. So dx goes from here and multiplies here. So we will integrate both sides. They are equivalent now. Integration of dy is just y. Integration of cos will be positive sine x minus pi by 4 divided by the differentiation of the angle. Differentiation of x is 1 and differentiation of pi by 4 is 0. So divide by just 1. So it will be plus c also. So y is equal to sine x minus pi by 4 plus c. This additional information of y is equal to 2 is to get the value of this c, and that's what we are going to do now. We'll substitute y equal to 2 equal to sine 3 pi by 4 minus pi by 4 and plus c. So 2 is equal to sine 2 pi. 3 pi minus pi is 2 pi. Because the denominators are same, we can subtract 2 and 4 also cancel, so it becomes pi by 2. Sine pi by 2 is 1. So 2 is 1 plus c, and 1 can go to the other side and give us c equal to 1. So our final equation of the y in terms of x is y equal to sine x minus pi by 4, which was already with us. Now only c was needed. We know c now, plus 1. This is the equation of the curve. In other words, y in terms of x. Well, let's go to the next one. Next one says that there is a function, this one, and we have to write down the equation of the vertical asymptote in this. So, okay. The vertical asymptote is always, a vertical asymptote looks like this. Yes. What is the value here in vertical asymptote? Nothing. It is undefined. In other words, they are asking us that 2x plus 4 should be over 3 minus x should be undefined, so that it does not have any y value, right? And when is it possible? When denominator is 0. Nothing is possible to be divided by a 0. That means if 3 minus x is 0, this whole thing will be undefined and we will get an asymptote. So 3x equal to 0 makes it x equal to 3. This is the vertical asymptote and the answer of A, part 1. Number 2, the horizontal asymptote. Horizontal asymptote for a rational function like this is decided by the leading coefficient of numerator. Leading coefficient of numerator is 2. So y equals to 2 divided by leading coefficient of whatever is the denominator. Leading coefficient will be x, to the coefficient of x will be minus 1, not 3. Okay, 3 is without x, so it is not leading coefficient. So that gives us y equals to minus 2. This is horizontal asymptote. B part, find the coordinates where the graph of f crosses x-axis. In other words, x-intercept. So whenever we want to find x-intercept, y is 0 on x-intercepts, right? If this is our Cartesian axis, if this is the x-intercept, definitely here y is equal to 0, isn't it? In this whole line, y is equal to 0. That's what we're going to do here. So 0, y means fx, okay? So fx is 0 and 2x plus 4 over 3 minus x. If we cross multiply, this 3 minus x goes and multiplies with 0 and becomes 0. So what are we left with? 2x plus 4 is equal to 0. 2x is equal to negative 4. So x is negative 4 divided by 2. So x equal to minus 2 is the point where it is crossing x-intercept. Obviously for y-intercept, x will be equal to 0 by the same reason. At y-intercept, x is always 0. So we'll substitute x equal to 0 in that. Y equal to 2 times 0 plus 4 over 3 minus 0. So y comes out to be 4. This is 0, this is 0. 4 over 3. That's the y-intercept. So we got everything from this question. What about next? Sketch the graph of f on the following axis, and let me take it a little up. Vertical asymptote was x is equal to 3 and horizontal was y is minus 2. Okay, x is equal to 3 somewhere here, so our vertical asymptote will be this. Alright, second horizontal asymptote is y equal to minus 2. So minus 2 is somewhere there. That's y equal to minus 2. Then our x-intercept was minus 2. X-intercept was minus 2, which is somewhere here. And y-intercept is 4 over 3, which is 1.33. 1.3 somewhere here. If we join these two, this is how the graph will look like. Okay. The second part of the graph cannot be here because it will be 2 to 1, and it cannot be here. It will be again 2 y's for 1. So obviously the second part will be here. Let's verify. Let me put x equal to 5 and see if we're getting something here in negative. So in this we will get x equal to 5. We'll put it 2 times 5 plus 4 divided by 3 minus 5. So 10 plus 4 is 14 over minus 2. Negative 7 makes perfect sense. Yeah. At 5 it will be negative 7 somewhere here. That's good. So this is the graph, and they ask us to sketch only, and for additionally if you want you can write the coordinates of these points. Okay. Function g is defined as this, ax plus 4, where x is a real number. Okay, a is also a real number, but x is not 3 obviously. 3 minus 3 will be 0. It will be undefined for x is equal to 3. Given that gx and g inverse x are equal, find. So let's find g inverse x first. So the original equation is this one, where gx I will write as y equal to ax plus 4 over 3 minus x. But for inverse, I have to interchange x and y. So x is equal to ay plus 4 over 3 minus y, and I have to isolate this y to get inverse. Let's cross multiply here. So let's complete. 3 times x will be 3x minus y times x will be yx equal to ay plus 4. I need to isolate y, so these must be together. So let me bring this y to the right side. So 3x minus 4 is equal to, it becomes positive, so a plus x y, both of them positive, right? A as well as y, both are positive. X rather, a plus a and x. So now divide both sides by a plus x so that we get rid of it from the right side. So we got y equal to 3x minus 4 over a plus x, which is nothing but the inverse we were looking for. But they have given a condition, gx is equal to g inverse x. So let's complete here now. Gx was ax plus 4 over 3 minus x. And g inverse x, we just got 3x minus 4 over a plus x. So now we have to find the value of a with the help of this situation. So we'll cross multiply again. So it becomes a square x, and x multiplied by ax is ax square plus 4a plus 4x. Okay, equal to what? 3 times 3x, 9x. 3 minus 4 is minus 12. Minus x times 3x is negative 3x square. And negative x times negative 4 plus 4x. Okay. Now we can simplify this one to a square x and 4x, they may be together. So a square plus 4x, they are together. Ax square is ax square plus 4a is alone equal to 9x plus 4x is 13x. Let's write it here. And minus 3x square I will write first because it's higher degree, minus 12. So now we can compare the coefficient of x square here and coefficient of x square. So it gives us a equal to minus 3. Let's confirm with this one also. 4a will be equal to minus 12 also because this is a constant, this is a constant. So a is minus 3 here as well. So this is the value of a. A is equal to minus 3, nothing else they asked. Okay. Next is logarithm. So solve the equation. This is base 3, this is base 2, base 3. So whenever we want to solve any logarithmic equation, the same bases should be together so that we can club them. So let me do that. Log base 3 square root x is already on the left side. I'll take this also to the left side, minus log base 3 4x cube. And we are left with only 1 over 2, and let's change this base also. So log base 2 3, I want to change it to base 3 so that I can compare with these ones. Whenever we want to change the base to a new base, just make it that base and write the main number they have with the log. That means we have just changed the base, but nothing is free in this world. We have to compensate this. It will be compensated this way. Log base 3 again, same base, but this time this base which we ignored becomes the main number here, right? I hope you understand. So we'll do it here. Log base 3 3 is 1, because when this base and this number are same, it is equal to 1. So this is numerator, mind it, this is numerator which I am writing at denominator because it was denominator here. So 1. And this denominator of this will become the numerator now, which will be log base 3 2. So basically reciprocated. It is 1 over something, it's reciprocated except for this 2. 2 was not part of it. Alright. Now these two logs are subtracting. So whenever two logs subtract, we divide the contents. So it will be square root x divided by 4x cube. Right? And here we are left with log base 3 2 and half in front. Yeah, this is base 2, sorry, denominator 2, so it will become half log base 3 2. This can be made exponent of 2 because I want to compare log base 3's. So the new look will be like this: log base 3 square root x over 4x cube equal to log base 3, and 2 to the power half is a square root 2. And now we can compare, not cancel. Normally we do like this, but this is not actually cancelling, it is comparing logs. So it will become square root x over 4x cube equal to square root 2. Now we have square roots here, so to get rid of them, let's square both sides. So this square root and square cancel, so it will be complete x. 4 square will be 16. X cube square will be x to the power 6 equal to square root and 2 cancel, so just 2. Cross multiply again. So what are we left with? X equals to 32 x to the power 6. Alright, I can divide both sides by x and I get one of the answer, but I will lose one of the answer. Never cancel them like this. Bring everything to the other side. X minus 32 x to the power 6 equal to 0, because they have something in common. If you do not take care of it, it will you will lose one of the answers. So I'll take x common from these two now. It becomes 1 minus 32 x to the power 5 equal to 0, because one of the x's is out. So now we have two solutions. X is equal to 0. This we would lose. 1 minus 32 x to the power 5 is equal to 0. This answer, even though it is additional, we'll have to reject this. Why? Because if you plug in 0 here, log base 3 square root 0, basically it will be log 0, and log of a 0 is not possible, so this we have to reject. But still, always do this what I have suggested. Here I'll take 32 x to the power 5 to the other side, and let's divide it by 32 here and 32 here. So x to the power 5 is equal to 1 over 32. To find x, we will find the fifth root here and fifth root here. Fifth root and power 5 cancel. X is equal to fifth root of 1 over 32 is half. This is acceptable solution. Okay. Question number 4. A bag contains 5 red balls and 2 white balls, that is box 1. Okay. Box 2 contains 4 red balls and 3 white balls. Okay. A box is chosen at random and a ball is drawn, and means they are independent events. Okay. Find the probability that the ball is red. So probability that it's a red ball will be in two cases. First, box 1 is chosen and then there is red inside that box. Or probability that box 2 is chosen and we have a red ball inside. These two are mutually exclusive cases. They can't happen together. That's why we wrote plus here. So probability of box 1 will be half, because there are 2 boxes only. Probability of red inside that box is 5 red balls out of total 7 balls. So 5 over 7. Plus again box 2 probability is half, but the probability of red ball in that will be 4 out of 7 again. So what do we get? 5 over 14 plus 4 over 14, which is 9 out of 14. That's the solution of A part. Move on to B. Let A be the event box 1 is chosen. Box 1 is chosen. So probability of A, event A will be half, because box 1 choosing its probability is half. Let R be the event a red ball is drawn. Probability of red ball is drawn is 9 over 14. We just got it in the previous part, correct? Determine whether event A and R are independent. Are they independent? We'll have to see that. So if two events are independent, probability of A intersection B, okay, B is a general, A is a general event, I'm not looking at this right now, is equal to probability of A multiplied by probability of B, and vice versa. That means if probability of A multiplied by probability of B is equal to probability of A intersection B, then opposite of this is there. They are independent events, and this is what they want to test. If probability of A multiplied by probability of R in this case, is it equal to probability of A intersection R? That's what we have to choose. So probability of A we just found half, multiplied by probability of R is 9 over 14. Is it equal to probability of A intersection R when both of them are happening? And both of them are happening here when box 1 is chosen and Box 1 is chosen and red ball is drawn. This is the probability of A intersection R, which is 5 out of 14. So 14 and 14 cancel. 9 over 2 is not equal to 5. This is not equal to 5. So we can write that the events A and R are not independent. Question number 5. Okay. The function f is defined for all real values of x. The line with equation y equal to 6x minus is tangent to the graph of f at x equal to 4. Let's try to visualize this. So suppose this is f function and this is the line tangent to it. The equation of this line is y equal to 6x minus 1 and the tangent is at x equal to 4. The x coordinate is 4. What is y coordinate? We'll find out later. Alright, write down the value of f prime 4. First derivative of function f at 4, and f prime 4 is nothing but the gradient of curve or tangent at x equal to 4. Yeah, at this point, whatever is the gradient of the curve, same is the gradient of the tangent, and that is the first derivative at 4. So basically the gradient of this line. So we know, let's write here, we know that y is equal to mx plus c, right? So in equation y equal to 6x minus 1, m is equal to 6 and c is equal to minus 1. This is y-intercept and this is gradient. And the question was, what is f prime 4? Is nothing but the gradient, which is m. 6 is the answer in this case. B. Find f4. So at this point f4, though they are asking what is the y value for f when x is 4, but we don't know the equation of the curve. What we know is the equation of the tangent, and this point is common with the curve and the tangent. That means if I substitute this 4 in the equation of the tangent, I'll get the y coordinate. So it will be 6 times 4 minus 1, which is 24 minus 1, 23. So y coordinate here, which is f4, is 23. C. The function g is defined, okay, it's a different function, all values of real numbers again, where gx is a quadratic, okay, function, and hx is f of the first part, gx, okay. Find h4. So C, h4 will be, by this relationship, it will be f of g4, correct? That means first I'll need to find g4. So g4 will be 4 square minus 3 times 4, which is 16 minus 12 equal to 4. Luckily, that means this becomes f4. We got f4. If it would be f5 or f8 or f minus 2, then we would not be able to proceed. But not by chance, by their planning of the question maker, we got the same thing, and f4 is already known to us, which is 23. So answer is 23. Okay. Hence, find the equation of the tangent to the graph of h at x. That means h is a different graph. So let me draw a different graph. Suppose this is the graph h. So we have to find the equation of the tangent at the same point, but new tangent, this one. That means we can't use this gradient anymore because it's a different curve. Only point is common, tangent can be different. And that's what we are going to do now. Equation of any tangent is y minus y1 equal to m x minus x1, and y is a general point. y1 is the point on the curve, and this point is common with h as well, so we can use this one. What is the y coordinate? 23 equal to m, we don't know, x minus x coordinate is 4. Only problem here is that we don't know m. Now let me try to find, it's not that m, okay, the m we wrote earlier, it is different m. So let me write m2 so that to differentiate it. So m2 will be h prime 4, isn't it? We know h4, but we don't know h prime 4. So we'll have to differentiate this. So let's do the normal relationship first. hx is equal to fg of x. So h prime x will be normal chain rule. First you differentiate the whole function, which will be f prime gx, and then multiply it by the differentiation of whatever was inside that function. We have gx inside the function, so now carefully look at this one. Gx is g4 because we are talking about this point. Yeah, this m2 is at 4, so g4 came out to be 4. So basically h prime 4 we are looking for will be f prime 4 and g prime 4. So which will be f prime 4 is known to us, f prime 4 is 6, we got it. G prime 4 is not known to us. So at the corner here, I will find g prime x first and then I will find g prime 4. So we'll have to differentiate this x square minus 3x, the main equation of g. So differentiation of x square is 2x, differentiation of minus 3x is minus 3. So g prime 4 is going to be 2 times 4 minus 3, which is 8 times minus 3, 5. So we got it, 5. m2, which was h prime 4, is 6 multiplied by 5, which is 30. And now we will use that here. Y minus 23 equal to 30x minus 4. And let's remove this from here and finish this. Y minus 23 equal to 30x minus 120. We can collect everything to the right side because 30x is positive here. So we can write 30x, then we'll bring this y here, minus y, then minus 120 is there, and 23 becomes positive. So we get our equation as 30x minus y minus 97 equal to 0. This is the equation of the tangent at x equal to 4. Alright, what is next? Question number 6. Show that this particular expression can be equal to this. Alright, so let me focus on right hand side. 2x minus 3 is a complete expression, and 6 over x minus 1 is a rational expression. So let me give this same denominator and multiply the numerator also by same, because I can't make changes. X minus 1 and x minus up and down, we can do that. So x multiplied by 2x square, x multiplied by minus 3 is minus 3x, minus 1 times 2 minus 2x, and minus 1 times minus 3 is plus 3 over x minus 1, and minus 6 from the second one, because now the denominators are same, we can combine them. So what do we get here? 2x square minus 5x, right? Minus 3 minus 2 is minus 5x, and 3 minus 6 is negative 3 over x minus 1, which is RHS. Sorry, it was LHS, left hand side. Okay, B, hence or otherwise, solve the equation 2 sine 2 blah 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 and this. So let's compare. Is this matching? 2x, 2 sine 2 theta, minus 3, minus 3, minus 6 over Sine 2 theta. So x is actually sine 2 theta. X has been replaced by sine 2 theta, and that's how we can make it like this. We can write it like this. So 2x square will become 2 sine 2 theta square. I'm doing B part here, okay? Minus 5x, minus 5 and sine 2 theta, minus 3 over sine 2 theta minus 1 is equal to 0. This is what we have to solve between 0 and pi, okay, in radians. This goes there and cross multiplies with 0, becomes 0. That means we don't have to bother about the denominator anymore. Just focus on the numerator. So it becomes 2 sine square 2 theta minus 5 sine 2 theta minus 3 is equal to 0. And we can use our calculator to get the values of sine 2 theta by using the equation function. By the time I use my calculator, I would request you to hit that thumbs up icon to like this video and share this video with your friends and subscribe to my channel. Thank you very much. I got sine 2 theta, which was the base of this quadratic, equal to 3, and sine 2 theta equal to negative half. A sine theta can never be 3, so that means this answer is invalid. We have to reject this one. This will work upon. So first let's see up to 2 pi. They're saying up to pi only, right? But because the angle is 2 theta, let's say up to 2 pi, how many times sine is equal to negative half? Sine is negative in this quadrant and this quadrant. And sine inverse half, not negative half, okay? Because I have chosen the quadrants because of the negative, so negative is ignored. Sine inverse half is pi over 6, 30 degrees. That's what I will write here, pi over 6 and pi over 6. Both the answers are in the quadrants which are above our limit. But no problem, because of this 2 theta, we'll come back. So what is our first answer? Our first answer from 0 is this one. So first answer will be 2 theta is equal to pi plus pi by 6. And second one will be from here till this line, which is 2 theta equal to 2 pi minus pi by 6. So in this case, it is crossing pi and pi by 6 more. That's why it is pi plus pi by 6. But in the second case, it is not reaching 2 pi. It is finishing pi by 6 before 2 pi. So that's why 2 pi minus pi by 6. So here we get 2 theta equal to 7 pi over 6. So theta will be divide both sides by 2, 7 pi over 12. This is our first answer. And here 2 theta equal to 12 minus 1, 11 pi over 6. And again it multiplies here by 2, goes here by 2. So 2 and 2 gone. It's 11 pi over 12. And if you see, both of them are less than pi. So both the solutions are acceptable to us.